Hey Pre-Calculus, today we're going to be starting section 5-1, day 1, Trigonometric Identities. So an equation is an identity. An equation is an identity if the left side is equal to the right for all values of the variable. Of the variable for which both sides are defined. For which both sides are defined. Okay, so we're going to start you off with 3 identities. 2 of the 3 you should already know. First one is the reciprocal identity. Or identities, because there's more than one. So your reciprocal identities are sine of x is equal to 1 over cosecant of x. Right, so this is an identity because the left side is equal to the right for all values of x, right, for which they're both defined. Cosine of x is equal to 1 over secant of x. Tangent of x is equal to 1 over cotangent of x. And then there's 3 more, and it's the reciprocals, right? So cosecant of x. Cosecant of x is equal to 1 over sine of x. Secant of x is equal to 1 over cosine of x. And cotangent of x is equal to secant, or 1 over secant of x. I say secant? Oh my goodness, guys, I'm rusty. Okay, sorry. Cotangent of x is equal to 1 over tangent. Yikes. Okay. There we go. So they're called the reciprocal identities because they are equal to a reciprocal, right? It's 1 over secant or 1 over cosine. Alright, then we have our quotient identities. And again, you should already know these 2. One of them is that tangent of x is equivalent to the ratio sine of x over cosine of x. And then the other is that cotangent of x is equal to cosine of x divided by sine of x. Now, the last identity for today is the Pythagorean identities. Okay. And the first one is cosine squared of x plus sine squared of x is equal to 1. And then we've got 1 plus tangent squared of x is equal to secant squared of x. And 1 plus cotangent of x is equal to cosecant squared of x. Okay, so you are expected to know and have these all memorized for the problems that we'll be using with them. It's not going to be too bad because you're going to be doing a lot of practice. So let's do some. Okay, so an example of one kind of problem that you'll have is simplify. We should have enough space here. So we're going to simplify cosine of x times secant of x divided by tangent of x. And when we're being asked to simplify, we're going to be using our trig identities and algebra, and our answer should either be a number or it's going to be a single trig function. So the trick is just to kind of look at each thing and be like, okay, well, what can I do with that? We're going to want to cancel things, right? So one thing I'd recommend doing is separating this out. You don't have to, but I think it's good for when you're starting to use trig identities for the first time. Right, so all I did here, and we're going to be doing proofs, so we want to get in this habit of stating the reasons. What did we do? So for here, all we did is just separate using, right, we're just multiplying, so like these are still equivalent. Okay, and then now, like, what could I do to cancel? And hopefully you're like, well, you know what, secant, I could change that to the reciprocal, and I'm doing that because I remember that secant is 1 over cosine of x. And then I don't want a fraction if I can help it, so I'm going to use the reciprocal identity again, and 1 over tangent of x is equal to cotangent of x. So what did I do here? I just used the reciprocal identities. Okay, and then as you can see, these are going to cancel, so I am just I'm left with cotangent of x, and we are left with one trig function, so that is as simplified as we can go. And that was just algebra. Right? If you like showing that stuff, I know some kids do. Right? These are canceling because cosine over cosine is equal to 1. So that's one kind of problem that you can have. Another problem, sorry if you can hear Coda whining outside. Another type of problem is a complete the proof. And we'll start off easy right now. So eventually you'll be doing the proofs completely on your own. But let's do a complete the proof. So you're going to complete the proof by choosing the rule that justifies each step. If you remember back in geometry, right, your proof has what you're doing and then the reasoning right next to it. So I'm going to give you what happened. So it started off as cosecant squared of x minus 1 times sine of x, and then went to cotangent squared of x times sine of x. Then that became cosine squared of x divided by sine squared of x times sine of x. That became cosine of x over sine of x times cosine of x. And then that became cotangent of x times cosine of x. So when you do this, eventually, you're going to be given what you're starting with and what you want to end up with, and you have to prove that this equals this. So for the example that I'm giving you, here's all the work. What is the reason? So how would we go from here to here? So typically when you see something squared, you immediately need to be thinking Pythagorean identity. And if you go look at your Pythagorean identities, I'm going to go quick here, right? Just take notes on them, right? There is a Pythagorean identity that involves cosecant. And here it's written 1 plus cotangent squared equals cosecant squared, but I could simply subtract 1, right? And then I'll have cosecant squared minus 1. So to go from here to here, that is using a Pythagorean identity. Okay. All right, so how did we go from here to here? So the sine x looks like it stayed, so how did we go from, cotangent squared to cosine over sine of x? And so if we're going from here to a quotient of two things, you can double check, but it is in fact a quotient identity. Right? Because you can even write yourself a little side note if you wanted to, right? It's because cotangent is cosine over sine. So because it's cotangent squared, it'll just be cosine squared over sine squared. So then from here to here, it might be a little less obvious, but this is just algebra. And that's because, right, sine and sine will cancel, right? So if I cancel out a sine with a sine, I'll have cosine squared over sine. And then it just was broken up like we did in the other problem. So it'd be cosine squared over sine. But it's separated because when it's separated, it's really helpful to go to the next identity. And we're going to change this to cotangent using the quotient identity. So basically, you can, I don't know, I'm gonna sound like a real nerd. I really like these problems. I think of them as like little breakout rooms, right? So you go into a breakout room, if you're doing a puzzle of some sort, you need to figure out like why this is happening or what's causing that. And that's gonna be the identities, and there's gonna be a lot of manipulation. So practice makes perfect. You wanna keep practicing problems like these and understand the identities so that you can manipulate it the way you want.